Hi friends, I'm Arasi. Welcome to Groovy Mathematics. In our last video, we discussed about equal number of nines multiplication. In this video, we are going to see about more number of nines multiplication. See this problem. Here, the number of digits is lesser than the number of digits of nines. Yes, we are going to see the problems of this kind and we are going to solve these problems without a pen and paper. Can we see how to do it? Come, let's do it. And to solve any problem in Vedic maths, we need some sutras, isn't it? Yes, the sutras used here is the same as the sutras used in equal number of nines multiplication. The sutras are Ekanyunena Purvena, by one less than one before, and Nikhilam Navata Charamam Dashataha, all from 9 and last from 10. Yes, by one less than one before means you are going to reduce 1 to the previous number which is there. And for all from 9 and last from 10, it is a very similar subtraction methodology which we use for is all from 9 and last from 10. If anyone is unaware of it, please go to subtraction playlist and you will be having a video over there all from 9 and last from 10. Please have a look on it and please then continue with this video, because we are going to solve these methods only using the subtraction. So you should be clear with that all from 9 and last from 10 subtraction. Okay, come let's go to the problem. Initially, I'm going to start with a smaller number. The first we are going to start with 7 into 99. 7 into 99. 7 is a single digit number and 99 is a double digit number. I know to solve this methodology, this number nines multiplication, if I have equal number of nines as we have discussed it in our earlier video, last video. So what I can do is, can I make this 7 a two-digit number? Would I be able to do it? Yes, I can do it. How I can do? I can simply add a 0 before a number. Let it be any number. We can add a 0 before that number and we can increase the number of digits. But can we add a 0 after that number over here? No, we should not add a 0 after a number of our own, because any number followed by zeros, the zeros following a number has a value in it. But a 0 before a number, that is the leading zeros of any number, doesn't have any value. So we can add any number of zeros here. So what I'm going to do here, I want to make the 7 a two-digit number. So what I did is, I just added a leading 0. Okay, now this number has become a two-digit number and I have two nines here. Now can I apply the same method which I used for equal number of multiplication? Equal number of nines multiplication can be applied here, because here too I am having a two-digit and here too I am having two number of nines. So both are equal. So I am going to apply the equal number of nines multiplication method here. For that, what I have to do, initially I have to split my answer into two parts, that is the LHS and the RHS. To get my LHS, what I have to do? To get my LHS, I have to find the Ekanyunan of this number, and for my RHS, I have to get the Nikhilam of this number. Okay, Ekanyuna means it is by 1 less than. So by 1 less than 1 before. So 7 minus 1 is 6. Okay, Ekanyunena of 7 is 6. And for my RHS, what I have to do? I have to find what I have to do? I have to find the Nikhilam of this number. Then for Nikhilam, it is all from 9 and last from 10. My last digit is 7 and my other digits are 0 here. So I have to take the 9's complement of 0 and 10's complement of 7. So 9 minus 0 is 9 and 10 minus 7 is 3. And my answer is 693. Here you may be having a question. Why I haven't taken 07 here? If you need, you can go for 07. But why I have left is, it is a leading 0. Before LHS, I don't have any other numbers here. But here in RHS, it is a continuity of the answer. The answer is being split into two parts. That is LHS and the RHS. So the RHS is a continuity of a number. So this 0 has value when it comes for RHS. In LHS, as it is the leading 0, it is not compulsory to take this 0. But if you feel it would be a confusing thing, just take it as 07 and give it as 06, and you can also make your answer as 0693, which is equivalent to 693. So there won't be any issue. If you feel it to be confusing, please go on with it. Just take it 07 and continue. Don't leave the leading zeros. Okay? Okay, come now let's go for the next problem. Next problem is 94 into 999. What I have to do here? I'm having a 2-digit number. Here it's 3 nines. I want to make this 2-digit number into a 3-digit number. For that, what I can do? Can I add a leading single 0? Yes, I can add. By adding a single 0, 1 0 leading 0, I'm making this number a 3-digit number. Now, number of digits in the number is 3 and number of nines is also equivalent to 3. So, I'm going to apply the same method used for equal number of nines multiplication. And what you can do, first initially, I have to split the numbers into LHS and RHS. So, for my LHS, I have to take the Ekanunena of the number, and for my RHS, I have to take the Nikhilam of my number. Ekanunena means by 1 less than 1 before. The number here is 94, so I have to less it by 1. 94 minus 1 is 93. And for my RHS, what I have to do? I have to take the Nikhilam of this number. That is the all from 9 and my last from 10. This 4 is the last digit. So I am going to take the 10's complement for this 4 and all the other digits are from 9. So 9 minus 0 is 9. 9 minus 9 is 0 and 10 minus 4 is 6. So my answer is 93906. 94 into 999 is equal to 93,906. Okay. In my next sum, see here. It is 618 and 99,999. Here I am having a 3-digit number and here I am having a 5 nines. I want to make this number a 5-digit number. So what I can do? Yes, I can add 2 zeros. 2 leading zeros I can add here. So my number, this number becomes a 5-digit number. Now it is a 5-digit number and 5 nines are there. So both the number has equal number of digits. I am going to apply the same method used for equal number of 9 multiplication. Initially I am going to split it into two parts, my LHS and my RHS. For my LHS, I am going to take the Ekanunam, and for my RHS and Nikhilam of the number. Okay. For Ekanunam means by 1 less than the before number. The number is 618. So 1 less of 618 is 617. And for Nikhilam, I want to take the all from 9 and last from 10 of this number. I have to apply 10's complement to the last digit. The last digit here is 8. So my 10's complement of 8 is 2. And for all the other digits, what I have to do? All from 9. So for all my other digits, I have to take the 9's complement. So 9 minus 0 is 9. 9 minus 0 is 9. 9 minus 6 is 3. 9 minus 1 is 8. And 10 minus 8 is 2. Okay. So my answer is 618 into 99,999 is equal to 17,99,382. Okay. Okay, come. Let's see the first initial sum which I have given for everyone to solve without a pen and paper. What I have to do here? the same thing. Let's first initially count the number of nines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here it is 12 nines. And here see 1, 2, 3, 4, 5, 6. I'm having only a 6-digit number. I want to make the 6-digit number into a 12-digit number so that I can apply the equal number of nines multiplication methodology. For that, what I have to do? Can I add 6 zeros here? Before we were adding 1 0 and 2 zeros. Is it possible to add 6 zeros? Yes, we can add 6 zeros because let it be any number of zeros. The leading zeros before the number doesn't have any value. So we can add any number of zeros. That doesn't matter itself. Okay. So I'm going to add 6 zeros before this number. 1, 2, 3, 4, 5 and 6. So my new number is this. Okay. Okay. Now what I have to do? I have to go for my answer. I am going to split my answer into two parts. That is my LHS and my RHS. To get my LHS, what I have to do? I have to take the eigendenominator of this number. And for my RHS, what I have to do? I have to go for the Nikhilam of the number. Eigendenominator means by 1 less than the previous number. The number here is 836927. So I am going to take the 1 digit lesser than this number, which is 836926. And for my RHS, what I am going to take? I am going to take the Nikhilam of the number. Here, the Nikhilam means all from 9 and last from 10. And the last digit is 7. I am going to take the tens complement of 7 and all. And for all the other digits, I am going to go for all from 9. So here I am going to take the 9's complement. So 9 minus 0, 6 zeros are there. For all the 6 zeros, I am going to get 6 nines. Okay. And 9 minus 8, 1. 9 minus 3, 6. 9 minus 6, 3. 9 minus 0, 9 minus 9, 0. 9 minus 2 is 7. And 10 minus 7 is 3. So my answer 836927 into 12 times 9 gives 8369269 99999 163073. Okay. Are you all very clear about it? Do you have any other doubt? If you have, please give it in the comment section. I'll reply it. See, we are able to solve this much big problem very simply, isn't it? Okay. To solve just by viewing the question without a pen and paper, to improve your speed, please frame your own questions and solve it by yourself so that you can practice and you will be able to solve these kind of problems within a second or two. Okay, within a second or two, just by viewing the question, you can write the answer. You won't be needing any time for it. Okay. So what we have to do here? We have to frame a question. But what is the methodology here? Number of nines is more, and the number of digits should be lesser than the number of digits of 9. Here, we have to make the number of digits equal by adding a leading zeros. Okay, then we can apply the same method which was applied to the equal number of nines. Okay, if you frame your own questions and if you try to solve using the same your own questions, then you will be able to understand the concept very nicely and you can crack it any problem within seconds. Okay. Thank you. Please do subscribe and thank you very much.